In this demo, we'd like to implement a simple Linux application which will display the output of a command such as process state. So I have here started Eclipse, and I will start by creating a new project, and because I've installed previously the window builder plugin, now I'm able to create an SWT, which is the standard widget toolkit project. So let's just give it a name to the project such as process table, and in here I will create in the source folder a new package. Let's call the package demo. Here I'd like to create a new type of resource, so I choose other, and in my case I will go to the window builder category, SWT designer, SWT, and in here I'm gonna create a shell. Let's give the shell a name like process table shell. Okay, and now the shell was created. As you can see, I'm able to design my shell, so I'll go to the design tab, and I like to execute in a console the process state command. So what the console is displaying, let's just clear up this for you and execute it again. As you may see, I have the following information. The first column is the name of the user, then I have the process ID, the usage of the CPU, the memory which I will display, and I guess probably I will display the command as well. So now let's go to our design and add what we need. I will go to my widget, first to my shell, and I'll choose the layout of the shell. So I'd like to have a grid layout, and for the grid layout I will then go and drop onto my form, I'll drop a table. So I'll select the table, and I'm not doing a drag and drop, but I'm activating this toggle button and then click inside here. So this is already grabbing the excess space, and it's filling the form vertically and horizontally, so I have to do nothing, but I have to add some columns. But then I go to the table column, I activate this, and just to be able to align them, I will just click here to add another column. The first column I'd like to display would be the process ID, so let's just give it a text which will be the process ID. The process ID, it's a number, so let's just align this to the right. Okay, then add another column in here. Okay, so the column for the username, so this will be the user. User, it has to be aligned to the left. Normally by default when I choose none, will be aligned to the left, but let's just, for the sake of the alignment, let's just put left here. Let's add another column, in our case for the CPU usage, so I will add another column in here which will be the CPU, and because this is a number I will align this to the right as well, and then another column for the memory usage. So this will be, let's just write it as such, it's a number, so I will align this to the right as well, and then let's add the last column, which in our case will be the command. So this will be the command. The command, it's a simple text. I will align this to the left, which is by default. Now let's just resize this a bit because it's too large to fit, and with this we'll have our UI. Let's go and select over here or in here the whole shell and give it a text which will be process table. Okay, and now I have to implement the display. If I go to the source, you may see that, let's just do a Ctrl+Shift+O to organize the imports. I have some unused imports. As you may see, when I'm creating the contents, I'm calling the constructor which by default it's generating the UI. This is how the tool is creating the text, it's creating the UI for me. But then I'd like to schedule periodically a task which will execute the process state command and display its output. So I will get the display, the default display, and I will call a timer exec. This is planning to execute a task, but it's in my case I would like, when the application is starting, I would like this task to be executed right away, and it's requiring a runnable. I will make my shell to implement runnable. So I say this will be the implementation of the runnable interface, which will provide the method run to execute the call. And because it's not implementing, I'll just do a Ctrl+1 and resolve it with the editor by letting my shell to implement runnable. If I go in here, of course I do a Ctrl+1 again, and then I implement the missing methods, which is actually one method from the runnable interface, which is the run method. In here I'm trying to execute some call which might throw an exception. In case I get any checked exception, I will catch this exception by doing nothing, but in the end, because the method has to plan the same task again, I will then re-register the call, but this time let's do it after 1 second. So this is in milliseconds, and 1000 will be 1 second. So basically, when the application is starting, I call this to execute and display the table for the first time, but then when the table is displayed, I will re-register the call after 1 second to execute the run again and display the status of the processes just after each second. Okay, so I will have a bit flicker on my UI, but it's not gonna be that much. Nevertheless, we can optimize this. Okay, so what I have to do in order to execute a process state command, the one that you know and that we have on Linux. First of all, we need a process builder. So I create a builder by calling its constructor to call the process state with the well-known argument to get all the details about the processes. And then I call the builder to start, and this will create a process. So I define the process as such. The next step would be to actually collect the output of the process. So let's just create a process reader, which will be our reader. The class does not exist, so I type Ctrl+1, I press Ctrl+1 again, and I choose to create the class in the same package. Now that the class has been created, I can instantiate this as a process reader, but I'd like from my process to take the input stream, which is actually the stream where the process is writing its output. So it's the output stream of the process, but for me it's the input stream because I'm reading from that. So now I press Ctrl+1 again and choose to create a constructor with such signature. So this is going to be actually a stream, sorry. So now that I've created this, I'd like to create a thread to collect the output of the process. So let's just instantiate a new thread. So I'll just create a new thread, and the implementation of the runnable will be the reader. So the reader will actually collect the output. So I'm making the reader implement runnable, and I choose to implement the missing methods. Now that the process reader it's a runnable, I can start the thread with this. Thread. No, it's just simple. Yeah, it's the thread. Yeah. So I will start the thread. Then I will join the thread with the caller. This means that I will have to wait until the thread will end, and then I also call the wait for of the process to be sure that the process has been finished. And then I will collect a list of strings, which will be the lines that the process had been outputted to the console. So I call the method getLines of the reader. The method does not exist, so I will create this method. Now, in the end, after collecting all the lines, I saved this just to be able to use the method in here. If the lines are null, or okay, if the lines are not null, actually, I'm expecting to collect something from the process, but nevertheless. So what I'm doing here, I will take the table that has been created for me by the UI designer and remove all its items. Then I will iterate through all the lines with a string variable called line. Okay, and in here I will then split the line. I will split the line by any number of spaces. This is in regular expressions. I'm quoting the backslash, and it's a space. This is a space, and this is at least one space. And then what I'd like to do, I like to create a table item, and this is a snippet that's able to create a table item for me. So let's give it a name. Table item should be fine. So with this table, I'm creating a table item, and I will set some properties of it. So first of all, the first column would be the process ID, and the process ID is actually displayed in the second row, in the second column, sorry. So this is the process ID. But what I have to make sure when I will create the output, I will also see this. So make sure that my process ID does not contain the text process ID. So I will then check if the text process ID equals to data of index 1. I will just continue because this is, this is the first column, sorry, the first row. This is the header of my table. So I take the process ID. The user, it's in the first column, but I display this in the second column. Then the second, it's actually the third one, it's actually the amount of CPU. The fourth one of index 3 will be the amount of memory consumed by the process. And if I look here, the 11th actually it's the command which will have the index 10. So this is the fourth column, and I'll take the data from the output which is on index 10, which is the 11th column. That's all that I do in order to display my table. But now let's focus on collecting the output of the process. So let's go in here and define a reader. I'd like to read each line at a time, so I'll create a buffered reader, and this will be created on top of an input stream reader which will wrap inside the stream. Then I press Ctrl 1 and create the field, because I'm going to use this stream outside as well. I need also to define a list of strings which will be actually the lines themselves. Let's just create the lines in here. So I will instantiate a new array list of strings, and then when I return the lines, I will just return this value. When I run it, I'll just do a while true, and I will try to read in a string called line. I'll try to read with my reader by calling the readLine method. This may throw an exception, so I'll surround this with try catch. In case I have an input-output exception, I will break from the while true. Also, if the line is null, this means that the stream has been closed. I will break as well. Otherwise, I will just add this line to the list of lines. Okay, so this is what I do in order to collect the output of the process. So now that I have my logic implemented, let's just right click and run this as a Java application. So as you may see here, I have, okay, it's saying that some font is missing, but this is, or it's deprecated, but I don't care about this. It's outputted on the error stream, but nevertheless it's not a real error. It's more like a resource missing. But except for that, as you may see, I have the processes displayed and the list is refreshing automatically. So the process with the ID 1 is the init process, which is booting the system, and so on. So eventually you may see from time to time that I also run the process state command. This is my shell, the one you may see here, and if I exit from my shell, it should disappear from here. So probably you are not able to notice that because I don't arrange that by the name of the command. But anyway, if you are scanning through to the list of commands, there is no bash running in here. Although I have some scripts running, also some interpreters like the Born shell. I saw an SH at some point, but anyway. So if I start a new command, a new shell here, then you will be able to see my shell running in here. It's not the last process running, because all the time I'm calling the process state in order to get the list of running processes, this one here. Okay, so nevertheless, if I start a new shell in here, you will be able to see my shell here as well, and then the process state, as you may see. If I do a command and I'm executing this in background, you will not see the command here because this has been terminated. So I can do exit from the shell, and you will see that the bash disappeared from the list. So it's refreshing. It is a form, it's a frame, it's a shell. We may optimize it because I'm losing the selection each time we rewrite the table. So one option would be to one improvement would be to actually recover the table item by the process ID and update the data inside the item, so that I don't lose the items each time I'm refreshing the table. But this is a nice feature that we can do. Nevertheless, the idea was just to be able to see how easy it is to implement a simple UI to consume shell scripts, to consume command line processes. Yeah, so thanks for watching.